A basketball team plays in an arena that has a seating capacity of 15,000 spectators. With the ticket price set at $14, average attendance at recent games has been 9,500. A market survey indicates that for each dollar the ticket price is lowered, the average attendance increases by 1,000. Find a function that models the total revenue in terms of ticket price. What is the price that maximizes revenue? And what is the corresponding attendance? This is more complicated than the last problem because in the last problem we were given the equation for the function, but here we have to find the function ourselves. So we need to start by finding a function that models the total revenue in terms of ticket price. Well, we know that the revenue, the amount that they make, is the ticket price times the attendance, or the number of tickets sold. So we need to find out how to write this as a function with a variable. Now we are told we want to find a function that models the total revenue in terms of the ticket price. So the ticket price is going to be our input variable, which will be x. So what we need to do now is figure out the attendance based on the ticket price. Now we know that the average attendance at recent games, when it's been $14 per ticket, has been 9,500. So kind of our starting point for attendance is 9,500 people, but we're told that a market survey indicated that for each dollar the ticket price is lowered, the average attendance increases by 1,000. So they get an extra 1,000 people for each dollar under 14 that the ticket price is. So the way that we can represent that is 1,000 times 14 minus x. Because if x is 14, then 14 minus 14 is 0, so we don't get any additional people. But if the ticket price goes down to 13, then 14 minus 13 is 1. That's $1 the ticket price has gone down, and then we get an extra 1,000 people. If it goes down to $12, 14 minus 12 is 2, so that's $2 that's gone down, so we get an extra 2,000 people, etc. So this is an equation that gives us the revenue as a function of the ticket price. Now what I want to do is I want to actually multiply all of this out so that we can get a better idea of what this looks like. So inside the parentheses, I'm going to start by distributing this 1,000. So 1,000 times 14 is 14,000, minus 1,000 times x is 1,000x. We can combine like terms now. If we take 9,500 plus 14,000, we get 23,500, and then minus 1,000x. And if we distribute that x out front, that gives us 23,500x minus 1,000x squared. So this is the expanded version of our revenue function in terms of ticket price. So we have found our function that models the total revenue in terms of ticket price. Now we need to find the price that maximizes revenue and figure out the corresponding attendance. So this is a quadratic function, and the coefficient on the x squared term is negative. So that means that we're going to have a parabola opening downwards for our function. And so what we need to do is we need to figure out what the vertex is, because that will end up giving us the maximum revenue. So the first thing I'm going to do is I'm actually going to rewrite this in standard form, because it's going to be easier for us to deal with that way. So negative 1,000x squared plus 23,500x. We know that the x-coordinate of the vertex, which we usually label with h, comes from taking the opposite of b over 2a. In this case, b is 23,500, so that's going to be negative 23,500 over 2a. Well, if a is negative 1,000, then 2a is negative 2,000. A negative divided by a negative is a positive, so we get 23,500 divided by 2,000. We can divide the top and bottom by 100, which will get rid of 2 zeros in each. So that is 235 divided by 20. And if we do that division, we get 11.75. So we were asked, what is the price that maximizes the revenue? We know that x represents the ticket price, and this is the x value that corresponds with the vertex. So the maximum revenue is going to come when we've got $11.75 tickets. So the best ticket price, or the ticket price that maximizes revenue, is $11.75. Now, if we want to find the maximum revenue, which we weren't actually asked to find, but let's do it anyway, the maximum revenue would come from the y value of the vertex, which we label as k, and we get that by evaluating our function at 11.75. Negative 1,000 times 11.75 squared plus 23,500 times 11.75, which ends up being $138,062.50, which I just did in my head because I am a magician. Just kidding. I used a calculator. Please use a calculator as well. So the maximum revenue is $138,062.50. And we were also asked to find the corresponding attendance. Well, we said that the attendance was given by 9,500 plus 1,000 times 14 minus x. So if we plug in 11.75 there, so I'm just going to write A for attendance. That is 9,500 plus 1,000 times 14 minus 11.75. And when we put that into a calculator, we get 11,750 people. So the corresponding attendance is 11,750 people. And so those are the answers to all of the questions that we might have about this situation. Sometimes students at this point get a little bit confused. They say, wouldn't we make more money if we increased the attendance because we can seat 15,000 people in total? But the problem is, to increase the attendance, to get more people to want to buy tickets, you'd have to make them cheaper. And in the end, that wouldn't actually help. The money you'd lose by making it cheaper would be even more than the money you'd gain by selling more tickets. So it's really a delicate balance. And you better believe that companies around the world are doing market research and doing calculations like this to try and figure out how much should we charge for the newest iPhone model so that we can maximize the amount of money that we make. How much should we sell this car for so that we can maximize the amount of money that we make, etc., etc. And oftentimes these are quadratic functions. because if we end up making something too expensive, few people will buy it and our profit's going to get smaller. And if we try and sell lots of them by making it cheap, we're going to be making such little money off of each product that our profit's going to go down. So there's going to be some point in the middle that balances having it cheap enough that people want to buy it, but also expensive enough that we're making a decent amount of profit off of it.